as a faculty member of a library school, my main concern for data science is whether data science, since it started, there's a NC State website states that data science started to rise in 2013. And so it's 3 years later. And my concern is whether data science has matured as a independent academic discipline, or is it actually still sort of taking pieces from different places, such as statistics, computer science? Does it, is it actually a clear, defined discipline? So this is Google Trends. And if you look at the different color, data science is in blue. It's rising a little bit, but a little bit flat. If you look at big data definitely rise a lot. And then we have yellow visualization and green informatics. They're sort of in a downward trend. And when I used Google Trend search, they listed related searches for different terms. So data science, there are different related search terms and big data. And your typical ones like data analytics and data science jobs and so forth. So when did data science as a term first occur? Actually, there are two different theories about this. One theory is this is actually data science or data scientist as a term occurred, was created by a person, it's the current White House chief data scientist, and together with a person called Jeff Hammerbacher. And in 2008, they coined the term data scientist because Jeff Hammerbacher actually works at Facebook as their chief data scientist. But another theory is actually by Jeff Wu, who works at Georgia Tech. In 1997, Jeff Wu did a talk at University of Michigan, and the title of the talk is Statistics Equals to Data Science, ? And in that talk, there's actually, you can Google it on the web, you can find his actually PDF version of slides. And then he talked about statistical triology, which include data collection, data modeling analysis, problem understanding, solving, decision making. And then he also pointed out that in terms of future direction of statistics, they will be facing very complex and massive data. And this is actually from his PDF. You can see that his proposal is let's use data science instead of statistics, data scientists instead of statistician. And he said, very interestingly, there are several good names being taken up, including information science, which I found it very interesting because I thought when you mention information science, people don't know what it is. But apparently information science to him is a very nice name. But he said because of these names are taken up, we probably should use data science because it's a sexier term. So he also said if we use statistical science, it's not as attractive, but better than statistics. So then my thinking is if this notion of data science is coming out of statistics, then what exactly is the relationship between currently developed data science academic program and statistic department program? So I looked at different descriptions of different degree program in data science and see how they define data science. So one of which is from University of Warwick in England. They have a bachelor in science, in data science, And then they mentioned data science as the interface of statistics and computer science. And the next one from College of Charleston, the program director of data science also says that data science is where computer science and statistics come together to shape the future through data. So apparently, one school of thinking is data science is simply statistics plus computer science, the handling bigger volume of data. So, in 2001, William Cleveland actually proposed a plan to expand statistics into data science. And there are 6 technical areas that he specified. And these 6 areas, he believes that the university can use this as a guideline to sort of allocate resources into developing a data science program. And also, this could be the makeup of the curriculum. So here is what he proposed. 25% will go into multidisciplinary investigations, because data science is multidisciplinary. And then 20% will go to models of methods for data, that's 20%. And then 15% is computing with data, 15% pedagogy. He believes that teaching method of data science is very important. And then 5% goes to tool evaluation, and 20% goes to theory. So this is something I actually want to talk a little bit more about. Exactly what is theory for data science? Do we have a holistic conceptual framework for data science as an academic discipline? So data science theory, this is both from Cleveland 2011, also from Oxford University has a data science program. They actually have a sort of program brochure, and then they describe what they consider as important for data science. And they stated that theory is vital to data science, and there's an urgent need to enhance the theoretical foundation of data science so that it can explain the model and model different data-intensive phenomena. So in Oxford's brochure, they actually said we have a lot of leaders in different kind of research which can contribute to the theories of data science. So they listed probability and statistics, expertise in probability and statistics, information theory in communication, visualization, algorithms, and quantum information theory, and philosophy of information. So there's a famous website called Masters in Data Science. They listed actually what are the foundations for data scientists. They grouped data scientists' core skills into 2 categories, hard skills and human skills. So hard skills, we have the typical mathematics, statistics, programming, decision-making, machine learning, visualization. But on the other side, human skill is something that not all the data science programs address, which is domain expertise, creativity and curiosity, storytelling, using data to tell a story, and project management, ethics, and you can do elevator speech. So what is the difference between data science and the original initial idea of statistics equals to data science? So there's actually a white paper written about defining what is data science by Mike Lukitz. And he stated that what differentiates data science from statistics is that data science is a holistic approach because we're increasingly finding data in the wild, and data scientists are involved with gathering data, massaging it into a treatable form, making it tell the story, which is the human skills we talked about earlier, and presenting the story to the others. And so in addition to just simplistically combining statistics with computer science, I also observed in looking at different universities' presentation of their data science program, including Syracuse University, which Jian is from, they actually are building their curriculum based on data life cycle, right? So Oxford defines data science as core issues related to processing of data, reliable storage of data, and management of data. Syracuse listed their courses that focus on handling data through its full cycle, which is architecturing, acquiring, analyzing, and archiving. I believe Jian will be talking about the story of their program so that she will be able actually to enrich what about their definition. So University of Virginia, UVA, has a so-called spiral learning framework, which I'll show you in a minute. They actually said we need to first give the student the base they need in languages, computation, and linear modeling, and then based on which we'll move them to more practical practice and application of data science. So this is the graph I created based on Oxford's description of their data science program. So they said the core things involve data processing, which machine learning and high performance data analysis, data management, data analysis, data visualization, data extraction and tools, data policy, and then they put theory. They believe theory is very important for data science to be an independent discipline. This is UVA spiral learning model. So on the basis, you can see languages, parallel computation, linear models, data management, and so forth. And on the top, you see the capstone. At the end, there are data mining, practice, and ethics in the upper location of the spiral. So in looking at data science and thinking about library information science, how can we contribute? Is this only computer science and statisticians' job to create data science? Even though we are talking about it includes both the hard skill and human skill, how can we, from library information science, contribute to data science? So the definition from iSchool or LS areas include some aspect of library information science knowledge. So G.F. Staten, also from Syracuse, defined data science as containing 3 areas: analytics and visualization, infrastructure, and the data curation. And data curation part is what he stated as really related to library information science. And UC Berkeley is the only school that provides definition that actually include information design in its data science definition. So it says data science is the intersection of the fields of social science and statistics, information and computer science, and design. So you see information science included, social science included, as having human aspect of related domain knowledge. This is actually Berkeley's DS curriculum. And you can see starting from, this is very research process oriented. Starting from the top, you have research design and cleansing, storage and retrieval, mining, exploring, data visualization, ethics and privacy, statistical analysis, communicating results. And it is MIDS, Master of Information and Data Science. So there are also some MOOCs certificates provided by Coursera and other platforms. I just give you some examples. It's actually, there are more than 4 examples, but I picked some examples for you to give you some knowledge of the courses, the program they offer. It's not necessarily a degree, but it's a certificate. So Johns Hopkins has this 10-course MOOCs data science specification or certificate, which costs over $400. You have 10 different courses. You can see that in the end, they do have a capstone. And all the courses actually, all the certificates, all MOOC actually have capstone in their program. And then University of Pennsylvania actually has a business analytics specialization, which this is the only one that I observe had people component to it, customer analytics and people analytics and so forth. And then we have UC San Diego and University of Washington providing different kind of specialization. So one thing I want to bring to your attention as we're talking about what exactly is data science as an academic discipline, this is actually a 2011 publication research work on looking at e-science, what kind of skills are core to e-science, and at that time e-science, 2 minutes. Okay, e-science is very much relevant to data science. So they actually interview people who have done internship in e-science and ask them to rate the importance of different skills and also how frequently they use the skills. So if you can see, I think this one, is that this one? Yeah. On the top corner, you see the most important and also most frequently mentioned is the people-focused skills. You have things like manage projects, analyzing project and research needs, search for materials online and so forth. And in the middle, you have data-focused skills, and then you have things like performing data cleaning, scripting, data quality assurance, and so forth in this circle. And in the lower end, which is least frequently mentioned and viewed as least important, you have the thing-focused, which is more programming, but really tied to a specific programming language or specific system. But this is the thing-focused skills. Okay. I'm going to skip because I don't have enough time. So me and Wa Salem, we actually did a study which will publish in 2016, Education for Information Journal. We look at 30 graduate data science graduate program and did a very thorough analysis of program description, curriculum structure, and the course focus. And we find a lot of problems with iSchools, the data science offered by iSchool. Their core coverage on analytical scale 1.0, which is the lowest, analytical scale is the lowest. And then core coverage on statistics and math is also the lowest. And core coverage on information scale, even though it's called iSchool, guess what? It's ranked number 4 out of 8 disciplines, so it's in the middle. And very low coverage on communication skills and non-elective, and very low core coverage on visualization skill or non-elective. So there's some gaps in iSchool's course offering. So these are the questions I have for the audience, but I'm going to switch to our next panelist.
One of the areas that I came from, and I came to data science too, is actually, interestingly enough, the digital humanities. And there's been, in the same way that folks talk about what is data science, I kind of am like, well, this is the conversation is very familiar to me because for over 12 years now, people have been asking the question, well, what is digital humanities? And there's a kind of an equally, not necessarily tense, but there are tensions around the meaning of the term, and depending on who you ask, if you ask 10 different digital humanists, you'll get 11 different definitions of digital humanities. And so it's very different, and digital humanities equally is not necessarily a discipline in the same way that English or history are disciplines. And I think there's some correlations here with data science, in the sense that data science is not necessarily a discipline in the same way that computer science or statistics are disciplines, but there is a very interesting, kind of relation, similar overlap and tension that between the digital humanities and the larger humanities, and I think between data science and the kind of the cultures of computer science and statistics, because not all computer scientists think, I've heard it said from computer scientists that data science is just a fad and it will pass, but we will continue to be here. Although there was a point in time when folks said computer science was just a fad, I believe, and so although we don't have, it's always interesting to kind of track the emergence of disciplines, and I like to cite the work of Andrew Abbott, who is a sociologist at the University of Chicago. He has a couple really wonderful books, the System of Professions and the Chaos of the Disciplines, which are all about kind of the emergence of knowledge work and information professions, and also kind of some discussions around disciplinarity in sociology. He's also done some really wonderful work on the emergence of social work as a discipline. So one thing to say is that as we kind of wrestle and grapple with data science, is it a discipline? What is it? That there actually has been wonderful work historically on the emergence of knowledge disciplines and academic disciplines that we can draw in and try and think about and possibly even use as theoretical frameworks for understanding what data science is. The one thing I will say is, the one last touch point I think with digital humanities and data science is there's a wonderful essay about digital humanities by Matthew Kirschenbaum, who is a professor at the University of Maryland, and he has an interesting essay where he calls digital humanities is a tactical term, and it is used to kind of enroll resources or people or interests or attention into various projects, and it is also a sexy term in the humanities. And I think data science, at least right now, is also, I think, best considered, as a term itself, and not. And I think actually, the notion of a discipline is actually a very interesting prospect for the future that I hadn't fully thought about. That it is a tactical term, and I'll talk a little bit about what I mean, how data science as a tactical term is kind of manifesting itself in academia. But a lot of actually what I understand, what I know about data science comes from industry. And comes from Silicon Valley, which is another social world of data science, and a radically different conceptualization of data science than I think what we are grappling with sort of here in the academy, and especially in the iSchools. And one of the classic definition when you talk to kind of folks out in industry about what is data science is they will say, well. And I don't have any. You're gonna have to use your imaginations because I didn't prepare any slides. But imagine a Venn diagram where you have math and statistical skills overlapping with what they call hacking skills or some kind of computer programming and data stuff. And then, and I hope I'm not stealing somebody's thunder. Or can you put that in your slides?
No, I'm not showing it.
Oh, you're not showing it anymore. All right. Well, no, please show it because it'll give a visualization. So you have the hacking skills, which are not necessarily breaking into banks, but the old notion of kind of hacking and just stringing things together with code and knowing how to write to manipulate data quickly and efficiently, or maybe quickly and not necessarily efficiently. But the final piece of that Venn diagram, the third circle, is domain expertise, and this is I think in the industry sector is often the one that gets the least attention paid to it, but it's the one that I think we in academia have the ability to have the most major impact with data science with. And I think part of that is because industrial data science or applied data science is kind of rapidly being commodified. We're seeing a rapid emergence of shrink-wrapped statistical tools that you are so easy to use that you really don't need to understand the underlying statistical work that's being done. And as long as you have the data, and as long as you can wrangle the data into the data store or whatever I call it getting data into shape or data fitness. As long as you can get the data and you have the hacking skills, which there's a lot of programmers now who are trying to transition into data science from kind of web application development or system administration, because there's a lot more money in being a data scientist, and it has a lot of cachet as a title. So people kind of are coming into that from programmers and becoming data scientists, where they can use the kind of the shrink-wrapped tools that are easy to use. It used to be Hadoop. It's now kind of Apache Spark, and now we're seeing Facebook and Google and other large, data-driven technology companies are releasing very well documented, very well designed deep learning frameworks like TensorFlow, which basically they're basically trying to own data sciences, to do Hadoop or to do TensorFlow and deep learning as essentially a mechanism of cornering the market for themselves. So you're seeing, because there's so much money on the table, this interesting relationship where the parts of the data science Venn diagram that can be commoditized and monetized are being so. But and I think hopefully domain knowledge and expertise will hopefully never be commodified. Mm-hmm. Although there is some attempts to do that, I think what we're seeing, kind of connected to the MOOCs and the programs to become a data scientist, we're seeing this rapid emergence of, give us $15,000 and 3 months of your life, and you'll become a data scientist at the end of the summer. So we're seeing data science boot camps. There's and Kaplan, the company that tests us all to death, is actually owns one of these. Mm-hmm. It's called Midas, not to be confused with another initiative at University of Michigan called Midas, which I'll talk about in a second. But there's, now there's all this emergence of, and there's actually interesting programs. I think it's called Data Insight in New York, which is a program that's basically their marketing is you have a PhD from mainly from the sciences, PhD in physics or in material science or engineering, but you don't have the hacking skills. You have the analytic skills, but you don't have the hacking skills to be a data scientist. And you don't have the social network in order to become a data scientist, because you've been kind of tucked away as a grad student doing graduate student things. But you're not necessarily interested in getting a tenure track job, perhaps because the labor market for academics is undergoing some tense period. And this is not true this is true for the humanities and for the scientists. There's a lot of PhD students and not necessarily academic jobs. So that's a market opportunity. And so there's now these camps where if you have a PhD, you can pay money and do one of these camps and learn kind of the software engineering skills that are desirable, so that you can go work at a technology company as a data scientist. So this whole kind of ecosystem has been kind of swirling and working in and around academia for a while. I think what's interesting, in my personal opinion, and I don't really have any evidence or data to back this up, is I did a degree in bioinformatics in the early 2000s. So data science and computational or data mining, that was what it was really trendy then. But computational science kind of left academia, entered into the industrial sector, and then got moved at the pace of markets as opposed to the pace of research. And it's now coming back in through these mechanisms of trying to draw out. We are constantly, our graduate students in some of the information science programs and computer science programs are getting drawn out into industry rather than going into academia, and sometimes not even finishing their degrees because they can get paid a lot more money at Google. And so now what we're seeing, I think, to kind of what I've seen in terms of data science as a tactical term is universities, a bunch of universities are launching big data science initiatives. And I don't mean big, I mean big in the sense that they're committing a lot of institutional resources. So University of Michigan, I believe, committed $100 million to Midas, which is their data science initiative. Ohio State has a similar one that I can't remember the name of. NYU, University of Washington, and Berkeley all received many tens of millions of dollar grant from the Sloan Moore, and I can't remember the third fund. Yeah. So tons of money. So Berkeley started the Berkeley Institute of Data Science, and now Berkeley is also, as Rong was showing, reconfiguring their whole curriculum around data science, not just in the iSchool, but at the university as a whole. So we're seeing, and Columbia actually just launched a master's program in data science, and I think they're trying to grow it into a doctoral program potentially. So there's a lot. Universities, I think, in some respects, are actually playing catch up. To try and configure themselves around this data science, this tactical term, which I do think will probably give it a little bit more reality than just some kind of fad. I think it's probably something that may stick, but I don't necessarily know. So the universities now they're playing catch up very, very quickly. I think all of these initiatives have been rolled out extremely fast in the sense of at least in terms of starting centers or initiatives, it's much easier to do that than it is to start a department or create a discipline, which no single university can do. But the emergence of data science as a discipline is going to take a little bit longer. So then one of the things I'm wrestling with now as a faculty member in a school of information and in a department of what used to be library and information science but has now been reconfigured and rebranded as the Department of Information Culture and Data Stewardship is how to bring, so we are starting a new, so at the University of Pittsburgh, our School of Information is now merging with computer science to create a center of gravity around computation on campus. So this is our version of we haven't quite gotten to the point of labeling it data science yet, but we do have programs in big data, we do have programs in information science and do data science-like things. So I think it's starting to manifest itself even here. So one of the things I'm trying to do is in my role as a faculty member in this information culture and data stewardship, which is kind of the non-technologically computer science oriented component of this new school of information, school of computing and information, is how can we take our master's degree program in library and information science and begin to add some data component, data. So we're using the term data stewardship, which has is going to have, there was kind of a battle between calling it data science, but it wasn't necessarily a data science program because we didn't want people to show up and expect to learn machine learning because that's not necessarily what this program is going to teach them. But we also, it's kind of more closer to data curation, but it's not exclusively about data curation. And so one of the things I'm working on right now, it's really literally like this week and next week is I'm working on a course that I'm calling Data Science for Librarians and Information Professionals. And I don't necessarily know what's going to be on the course. I'm still writing the course proposal and specking out the syllabus. But it's going to be we already have data curation and research data management, research data infrastructure classes in this trajectory. So I'm trying to find another space inside of this curriculum where we can introduce students who kind of are coming from, and they come to the program because they want to be librarians, and that has that concept, that has a lot of meaning and a lot of weight as a professional identity. And there's a long history with that. And part of what happens in our library programs is giving some more complexity and depth to what a librarian does. Is it's not just a person who manages books. And a lot of times we have students who come in, well, I just really love books and I only want to do things with books. And so there's a bit of trying to expose them to a broader understanding of what librarianship is, but also just trying to bring them into a larger professional identity around information professionals, which is not necessarily, doesn't have the same weight as a librarian does. So there is value in the professional identity of librarian, but the real question becomes, where does that situate itself in relationship to data science, or to data scientists, which is this new, rapidly emerging professional identity. So what I'm trying to do is kind of try to find in the course a sweet spot between, that builds upon their the things they will learn about research data management and data curation, but also expose them a little bit to some of the more technical stuff. I'm not in the span of one course going to have time to teach them about Bayesian statistics and machine learning, but I might be able to kind of just give them a quick understanding, so that they're not, when they hear machine learning, they know what it is and what it means, and when they hear about Bayesian statistics or deep learning or any of the, whatever the next hot thing is after deep learning in the data science world is, that they know what some of these analytic pieces are, and also that they get exposed to some of the infrastructures, like understanding what Hadoop is and why Hadoop was so significant in the MapReduce paradigm of data processing, and exposing them to kind of a conceptual understanding of these things, so that they can begin to talk about it and communicate effectively with data scientists and communicate effectively with other members of a data science team. Because really what I'm trying to do is put somebody who is exposed to the LAS training from our program and get them to be a member of a data science team wherever it might be, in an academic unit, if it's out in industry at a technology company, or if it's in a cultural institution like a museum, a library, or an archive. Because there's going to be data science practice in all of these places, I believe. Even libraries are going to actually start having data scientists who do data science. I know OCLC, I was speaking with somebody recently, they have a couple of people who are taking the Coursera data science MOOCs to learn how to do, and learning data science so they can actually do kind of data science on OCLC's data and also provide data science products. It's a very, interesting, we actually have a lot of data that in libraries that we could do data science on, and where, how do we get that type of person to come and work in a library as opposed to go work in Google? Yeah. Oh, yeah. So anyway, the last piece I had was, so we have this tradition of libraries, which is, has a very strong professional identity, and then we have this new, rapidly emerging professional identity of data science, and basically what happens when an immovable object meets an unstoppable force. And I think that's essentially where we're at right now.
I want to thank Elaine and also the E-Science Symposium to give me this opportunity to talk to everyone here. I guess as far as for data science in LIS, I guess I'll skip all those background and also the the basics and also the trends stuff. But what I'm going to do is I'm going to tell the story from a very practical perspective. This is the data science on the top, and on the left is the methodologies for data science, machine learning, and etc. And then on the right side is the domain applications. And long story short, it's just they have various kinds of data, and they came to us initially ask how to use Atlas TI to analyze their data. And then as we go along and ask, after back and forth, questioning and consultation, and it turns out they have actually, the bottleneck problem was the data management issue. So not a problem of using certain tools. Okay, this is one story. So this is the analysis, basically, analyze, understand what the problems are in their data management. So sometimes the data came up not as a data management problem, but that's up to you to find out. And the second story is also, from the time when Thea was at our program. This is another group's project. The domain is thermochronology and the tectonics domain. And basically, they do analysis on the rocks. And the rocks are collected from all over the places, and they slice it, and then they grind it, and then they analyze the mineral components in the lab, and they do laser, use those laser and also the radiation to test the age of the rocks in order to analyze what happened, millions of years ago at that particular place. So basically, they have a bottleneck problem. That's they generate tons of Excel sheet of data, and these Excel sheets of data are not in uniformed format. They sometimes mix the annotations in the data, and the data fields are not always the same. And sometimes one file contains multiple data sheets, and so on and so forth. So they have to manually piece together, hundreds of spreadsheets data together in order to present the large picture of their research findings. And so this is the whole, basically what's involved. We have to understand their workflows in order to understand their data management problems. Okay, and this is another story, and which is recently involved in my one of my research projects. So we got this grant from NSF to do data mining from the GenBank database. Of course, I'm no biologist. So I'm just using the metadata describing the DNA sequence to study scientific collaborations and to trying to find some patterns about, say, how collaboration affected the productivity and how to assess the impact of cyber-enabled research support to research productivity and knowledge diffusion, knowledge transfer, and so on and so forth. So the data, the metadata is semi-structured data in plain text format. So we had to write code to parse the data into a relational database, and then it's it's really huge. The GenBank data started. We collected data from the very beginning, which is late 80s up till 2013. So I think there are. I don't remember, but over 1 million annotations, DNA annotations. So the authors and in about more than 500,000. So there's a lot of it's a huge data, and basically the extremely large data sets with multiple entities, which makes manual processing impossible. And there's also a need to disambiguate author names and in order to correctly link between entities. So to generalize all these, I put the analysis of data problems as one of the focus of training our students, and also I think as a data librarian or librarian in the e-science era, and this ability to analyze data problems is critical to have the vision for future service development, as well as the ability to perform new services. So this domain analysis data is not just analyze quantitative data or but it involves requirement analysis, workflow analysis, data modeling, data transformation needs analysis. Remember, I want to make sure this is not data transformation analysis, but transformation need. You need to have that vision, what kind of format, the data analysis software needs to be, fed into, so you can put the data into as closely as possible to the analysis ready state. And data provenance needs analysis. I think data reproducibility was mentioned this morning in the keynote speech. And this is also another important area. So in order to perform these analysis of the domain analysis, of the data problems, domain data problems, and I think from my own experience as well as working with librarians, and interview skills, analysis and generalization skills, and these are very important, and also ability to capture components and the sequences in workflows, and ability to translate domain analysis into data models. So when you talk about you are seeing some text document, but in your mind, if it's needed, you should have that ability to envision what data model and how data might be turned into structured data, and have that kind of technical thinking. And ability to envision the data model within the larger system architecture. So these are the skills required to perform analysis of domain data problems. And I think in this data science, large umbrella, under the large umbrella, we cannot be, well, I shouldn't say this. Many of us, although will not be statistics experts, not a software engineer or professional level degree programmer, but we should be able to have the ability to communicate with these type of professionals. So another example I want to bring is right now I'm collaborating with faculty at Syracuse who is played a big role in the gravitational wave detection recent event. I don't know if many of you, but this as we are developing this metadata model for gravitational wave research data management, and we actually talked many rounds with the scientists, interviewed scientists in order to draw this workflow, to understand what's, step by step, what's needed along this process, understand research life cycle, workflows, the steps and the relationships, data flows, and entities and attributes, relationships, and the researchers' practice and habits in documenting and managing data. And this is another example that I mentioned earlier, and this is the, I think the sample record from GenBank. And as you can see, this is a plain text format. And so we use this, there's a lot of data management, data analysis, and data curation issues that I could have talked, but due to the time, I would not be able to, give a lot of details. But what I really want to show you is this diagram that I created. So for data science and library e-science librarianship, I think there are two areas that we can think about. One is the data services that support research, learning, and policy making. That's the external ones. And then there's another type of data services. I call it data-driven services. That support library planning, management, and evaluation. That's the internal data services. So for the external, we do data curation, data discovery, data consultation, and data literacy training to faculty and the students, and data mining. And I still remember Yale University, a librarian from Yale University last year presented a project he did through mining the Vogue magazines keywords over the years, and that was a really interesting project. And the findings were actually can actually be helpful for humanities faculty and the students for research and learning. And data collection, and the collection has two meanings. One is the collection as something physical there, but also collection is active, action. You collect data, and so that's another. Data integration, and of course, data integration means it's a very has many meanings, but I'm not going to be able to cover them all here. But I'm going to show this last, although I have other slides, but I'm just going to show this last one. Data-driven organization. I think when we talk about data science, educate our students to become data librarians or e-science librarians. And us library, and we want our library to be data-driven, and of course that doesn't exclude other driving forces like user-driven or policy-driven. It's just one aspect of the in this data science data-driven environment. So if we want to ask, is our library a data-driven organization? And I think that goes back to the two areas of data services and data-driven services. And when we at Syracuse, when we have set up the curriculum, when I teach digital curation, or we call it actually fundamentals of digital data, we're still debating whether to use digital curation or something else, but that is the title we currently have. So we are trying to implement, to cover these two areas. I think for a data librarian or for a modern librarian in the e-science environment, data-driven environment, we have to have this type of thinking and corresponding knowledge in order to provide, or not provide, but to design services proactively, and then have the skills to actually implement them and evaluate them too. Okay, I think I'll stop here and allow some time for questions.
One thing I think is we shouldn't think of a technical term as a negative piece. But we should take advantage of it. And I think you're completely correct that. I think data science is also moving faster than Unfortunately, Google isn't hiring digital humanists at six-figure salaries as much as I would love it to be the case. So data science has a reality to it that I think that it is probably, you're correct, it's moving beyond that. And I think as it becomes a discipline and as it becomes a profession and kind of fleshes out in that depth, I think. One of the things I think this notion of it needs a theoretical framework is absolutely crucial. And another conversation we were talking earlier, and a conversation I have with a lot of my colleagues is it also needs an ethics.
Yep.
And it needs to have a sense of what is our moral responsibility, or what is our professional responsibility as data scientists? So there's a really wonderful article by Greg Lieser, who's a professor at UCLA, talking about the responsibilities of professions, and he talks about kind of in the health professions, or in the medical profession, the kind of core value is around health, and in the law professions, the core values are around justice And in the information professions, the question is, what are our core values that we are trying, and I think data science needs to kind of start thinking about these questions that are not like technical questions. They're much harder, they're more people-centric. What is our responsibility to individual communities and to larger bodies of into organizations? So I think, yeah, I agree 100% with everything you're saying. And that maybe, that was a thought that I had about the tactical term, and I think it is simultaneously probably being used as a tactical term in some areas, especially more on the industry side than it is, I think, than in the academia, where if we are trying, as we try to make it a discipline, that's going to have a lot more heft to it. I don't know if you wanted to add anything to this.
I have a question for Jian.
Did you say you were combining the high school with computer science?
Yes, at Pitt, yes.
At Pitt. Could you talk more about that?
Yes, and I'm not the best person to ask, since I'm a visiting faculty member. I'm not always invited to the conversations. So this is not, so we are not the first iSchool to do this. There are many iSchools that have merged with their computer science departments. I think most recently Drexel was the last one to do it, I believe. Although actually I guess that you all at Simmons have done it as well. Although I think the configuration at Simmons sounds very interesting and slightly differently.
We absorb them.
They absorb, yeah. Usually it's the case computer science eats the information science. So I'm very interested to hear that Simmons, did it the other way. But we use the term merging because I think there's still it's complicated. So the Pitt Library, the School of Information Science at Pittsburgh used to have 3 degree programs: telecommunications, information science, and library and information science. And now that is all being reconfigured to this new School of Computation and Information Science. Will have 3 departments. It will have a computer science department with a PhD. I think it has a master's, or maybe I can't quite remember, or it may or may not. I think it will, and an undergraduate program. And then there will be the Department of Information Science and Network Systems, which is the merger of information science and telecommunications. That's very focused, still very computer science and techie heavy, but also with a kind of networking and telecommunications and information security component to it. And they have a PhD program, a master's program, and they are I think going to have an undergraduate degree program. And then there's the what used to be the Library and Information Science is now Information Culture and Data Stewardship. We have a master's and a PhD program, and we're currently in the very beginning stages of developing what I think will be an undergraduate program. But it's very complicated. We're not sure exactly how it's all going to look, because there's so much politics and so much turf, and we're taking the computer science department out of another school at the University of Pittsburgh and bringing it into our school. So this is it's. One thing we have learned at looking at the other instances of this, it happened at Indiana, it happened at Irvine, is it's always fraught. And it's always not, it never moves smoothly. And sometimes what comes out the other end often is the case. Traditional library science programs are often the big losers, which is really unfortunate. But it also could be a really big opportunity, and that we're trying to take it as an opportunity to kind of re-envision what it is, the kinds of work that we do.
Any last minute comments?
I know you had a comment.
I have a question for Jian, but yeah.
I think merging with computer science always has huge politics issues, and that's not the best solution. I mean, at least at Syracuse, we don't even want to try it. But what program we have developed over time, because we started this actually data science or e-science quite early. I think that was around 2006. And then over time, we have evolved from purely serving scientific data management, and then into e-science, and then into now data a certificate for advanced study in data science. So it's 15 credit program and can be done completely online. And so this, so that kind of mitigated the conflicts between computer science or information management and library science. And I think right now about 1/3 of our MLIS as students do take the data science certificate, and that have been a great help for anyone who wants to acquire knowledge and skills in the data science, have the option. And this certificate is very strong when they going out to either take a job at a company or take a job in the library market. So, so far it has worked well, but I think our school is thinking about having a degree program for data science. And that's the direction I think Syracuse is going for.
So we need to move into